All right, so back from that little interruption there. So as I was saying, when we are looking at algebra, oftentimes we will work with formulas, and formulas have only letters generally in the form of an equation, right? And when we have in that equation, when we have one letter by itself, that letter is often referred to as the subject. And when you have on the other side of the equation, you have letters that are together, whether you're multiplying them or adding them, subtracting them, or so on, those generally form terms or expressions, right? Now, most often when we're working with a formula, we are really trying to solve the subject of the formula, meaning that we want to work out or calculate what the value of the subject is. So what will generally happen is that if you're given a formula like this, you may be given the value of m. So they will tell you that m is equal to, say, 6. And if m is equal to 6, and you know that g is equal to 10, then clearly with those values, you are now able to solve for w using the formula, because all you'd have to do is plug in those values in the formula where you have m and g. So you put the number, the actual number for m. Now, when you're working with formulas, two letters together, there's an invisible multiplication sign. So once you put in numbers, the multiplication signs have to reappear, right? So mg would be 6 times 10, because we know that m is 6 and g is 10. And so we could now calculate what the value of w is by simply multiplying 6 times 10. So we see that w would work out to be 60. Now, if we know the units for w, which is weight, it would be, weight is generally in the form of a force. So we would say, we would measure it in units of newtons. So that would be 60 newtons, because weight is a force. And so the unit of force is newtons. So we would have 60 newtons. All right. So algebra kind of help us out when we have to use formulas, and formulas are reusable equations. And you have unknowns in the equation that left-hand side, you want to find the subject. On the right-hand side, if you get those values, you plug them in to the right-hand side of the formula, do your calculation, and you get the solution to the subject. Is that clear to everyone? Raise your hand if you understand clearly what I was just saying. All right, good. So it means then algebra has its purpose in math, because not all the time that you will be working with specific values. Sometimes you will be working with general values. And when we're dealing with a general values, we usually use a symbol or a letter of the alphabet to represent that quantity. All right. Sometimes we don't want people to know what that general value is. And so we might say, let it be X. All right. Now, if you should go away and buy some stuff abroad, and you come back with a nice pair of shoes, and your friend might be looking at the shoes and curious about how much you pay for it. Now, if you so desire, you can tell your friend, well, it is $60. But suppose you don't really want your friend to know how much. You say, all right, I pay X amount for it. Now, so the $60 there is a specific value, but the X dollars would be a general value, meaning that that value X can be any value that you want it to be. All right, that's why it is called a general value. Any question, guys? All right, no question. Now here we are going now to geometry. Now geometry deals with the calculations of angles, dimension. And when we talk about dimension, we are simply talking about the length, width, or height of an object. So if the object only has length, or if it only has height, we say that it is one dimension. If it has a length and a width, we say that that is two dimension. Now, if you look at these objects here, this ruler has length and it has width, so it has two dimension. Now, what about this triangular shape here? How many dimensions is here? It is actually two dimension, even though it shapes has three sides. Now, why it is two dimension? Because two dimensions are generally flat surface. So anything that have a flat surface, we say we have a two-dimensional figure, right? So a ruler is flat, it has length and width, it is two-dimensional. Now, what about this cube down here? How much dimension you have down here with the cube? Anybody? Mr. Shanti, how many dimensions the cube has?
I think it's 3, sir.
Okay. Anybody else agree with Miss Shanti, Ashanti? What do you think, Mr. Ojeno?
3.
3, right. So for 3 dimension, you realize that you're not working with a flat object. So you're working with an object that has length, width, and height. So in the real world that we're living in, our space is in 3 dimensions. When you go into your room has length, it has width, and it has height. So the space within your room is a 3-dimensional space. When you look at a person, the person have some amount, the person have height, the person might have some width, and if you think of the person thickness from front to back, that would be the depth of the person. So that's also a 3-dimension. So anything that you're seeing in the real world would be 3-dimension. Now, on the television, you may see things mostly in 2-dimension. And sometimes if you go to the movies where they have a 3D movie and you wear those glasses, it looks 3-dimension as if you're in the real world, right? All right, any question about arithmetic, algebra, and geometry? I trust that you would all know what the difference of these are and what part they play in mathematics. Raise your hand if you think you understand the part and purpose these broad areas of mathematics are. All right, Ms. Wilson, what else? Mr. Shanti. And okay, so I'm taking it that you understand clearly what the broad areas of mathematics are about. All right, now, just to make note, mathematics is a subject of logical reasoning. And I had mentioned to you what logical reasoning is. So when you're doing a logical reasoning, you're aiming to find out the truth And if something is not true, then it is false. So in the world of logics, something can either be true or false. And sometimes if it is not true or false, then you can imply, right? So logics has to be either you're true or you're false or you imply, or there are other aspects of logics that we're not going to even touch. But that's the idea behind logic. So you can either say whether or not something is true or false. Now, mathematics is a logical subject, meaning that it obeys true or false principle in terms of solving problems. So it's either right or wrong. Now, mathematics require an understanding of concepts, definitions, and symbols. So even though I won't be giving you a test on the concept or the definitions, you are required to spend some time to learn and understand, have knowledge of the definition and understanding of the definition. And so you'll be now able to apply based on your knowledge and understanding of concepts and definition. You can apply yourself to the maths problem. Now, we had mentioned reasoning before. So reasoning is a process by which the mind moves from a certain data to a conclusion not given. So as I was saying, example like the car accident. So you move from where? You move from, is a process where the mind moves from a certain data. So in the car accident, you investigate and collect data, right? So the data is the evidence that you're collecting. And so once you collect the data, then you're going to use the data to come to a conclusion. So if you collect enough evidence and you reason with the evidence, then you can say, okay, this man is wrong because this data is saying so and so. Is that clear, guys? All right. Now, data is evidence, and evidence generally consists of facts. So we have to understand that facts are things that we can verify, either true or false. I mean, a fact is generally considered to be something true. But a fact is not something that is static, meaning that what is a fact today might not necessarily be a fact tomorrow. So a fact not necessarily be permanent. You may have a green wall today because you paint your room wall green, but 2 days from now or a week from now, you could change it to another color. And the facts would have changed from green to another color. Everybody understand that, guys?
Yes, sir.
Right. Now we have also opinions. Now, one of the things about opinions is that we cannot say whether or not an opinion is true, because an opinion is just what somebody come up with in their thinking, their thoughts about what they think happened without any data. They give you an opinion. Like, person might just come on to the scene of the accident and say, yeah, man, the bike man wrong. But he didn't take the time out to gather data and do an investigation to the data and reasoning with the data. He didn't take any time out to do all of that to come to his conclusion. He just basically looked at the bike and say, this person is wrong. And so with opinions, you may have biases. People will bias based on opinion, because if you have a strong feeling towards something, then you will be biased towards that thing. Now, you may have a friend that is arguing with some other person, And you may have a tendency to be on your friend's side, even if your friend is wrong. That means you have a bias towards your friend. It's like parents and children. Parents will always defend their child, even sometimes when they're wrong, right? So opinions are like that. You will have biases because you just want to believe that whatever you're saying is correct, should be in your favor, right? Now, we have two main kinds of reasoning in general. We have inductive reasoning and deductive reasoning. Inductive reasoning is where you move from the particular to a general situation. So in other words, with inductive reasoning, you may see a little problem and then you do a little experiment and investigate the problem. And then after you do all of that investigation and experiment, let's say that you're doing your experiment on the growth of trees. And so you may want to see how fast trees grow. So you get different seedlings and plant them, and then you go every day, you measure them and you collect the data and you record the data. Over time, you will compare which one of them grow faster based on, so you can use based on the height. Now, when you do that experiment to one plant, you see that you get a certain conclusion from that data. So that is what we call the particular. So the particular experiment that you did, you get a conclusion from it. And from that particular conclusion, now you're going to make a general statement. So in the particular experiment, you may see that plants grow at a rate of 5 inches per day, right? So you come to that conclusion. Then that is just for that particular plant. But you may say that all plants grow 5 inches per day based on that one experiment with that one plant. So you're moving from a particular experiment and going to a general conclusion. Is that clear, guys? Raise your hand if you understand what I'm saying. All right, good. So now we have also another reasoning that we call deductive reasoning. Now, whereas the inductive reasoning go from the particular to the general, the deductive reasoning goes from the general now to the particular. So they're kind of like reverse of each other. So with the deductive reasoning now, you look at a general situation and see what the patterns are in that general situation. And then now, based on that general situation, you will conclude that it is the same for a particular situation. All right? An example of that would be what we have here in the sequence of letters. So if you look at this, what is generally happening with these letters? Can anybody see any pattern in the sequence of letters here? What really happening?
One letter skip each time, sir.
Right. So that's a general pattern. That's a general thing about this sequence of letters. So with that now, we see A, skip B, then C. Then we say C, skip D, then E. Now, what is it that you're expecting to see in terms of the next letters? What other letter you expect to come after?
You'd skip F, sir, and have G.
Right. So you skip F and you have G. And then you would also, if you continue, what you would do?
Skip H.
All right.
And I.
Now, how did you come to that conclusion?
Based on the pattern.
Based on, right, so the pattern is what you look at in the general sense. So generally you say that this is what is happening. So it must be the same thing that's happening with the other letters that come in along, right? So this is what we call deductive reasoning. So the deductive reasoning look at a particular pattern of a general situation and apply it for the individuals. All right. Any question so far? Any question, guys? All right, so if there's no question, I'm going to be ending class here today. And looking forward to see you when next we meet on Tuesday at 5:30. Now, 5:30 is sometimes working out to be 6, depends on how early you get here. All right, so we intend to start 5 if everybody comes at 5 on time. But if you don't reach 5:30, then we'll wait until everybody gets here by 6. Is that clear, guys?
Yes, sir.
All right. Any question that you'd like to ask before I leave? Yeah. Any question, guys? All right, so if you don't have any question, I'm going to be stopping here for now and we'll continue.
Sir, let me just to refresh my memory. I know it's probably a bit earlier, but I remember the last time we had a conversation last year as it relating to sitting the CSEC exam, sir. You were saying that even though we are doing the study with you, we could actually do the exam here in Westmoreland.
Right, so that's the goal. The goal is you find out the closest center to you, get registered at the center, and just register to do the exam. Now, depending on where you're registered, they may or may not insist that you do classes with them. You can explain to them that you really are not going to do classes with them. You just have to be able to do the exam. If they allow you to do that, then you do so. Now, if they ask you about SBAs, then you refer to them that you already have someone who will mark your SBAs. So, so you will be able to submit an SBA for that purpose.
And we don't do registration until we get the fee that is due for the subject. That's when we would actually go to the wherever and make the payment.
Right. So registration is not completed until you pay CSEC. And
okay.
All right.
Yes, sir.
Right. So you may also want to seek that center that you may want to do the exam now, because this time to October, you will find that they will require you now to start paying for the exams. So I would say if you have funds available, then put some aside so that you can have it for the exam when they call on you. All right?
Okay, sir.
Just to give you a sense of, you know, it has been a while since the pandemic and all of that. So I'm not sure exactly how much a subject will cost, but from those times, one subject would probably work. The subject fee would be probably about 9,000 somewhere there. And the registration fee would probably be another, say 3,000 to 4,000. And so sometimes the school charge a little service charge for paperwork. It might be another 1,000 or so. So you're looking generally say a 15,000 overall for everything. Don't hold me to that figure. You will have to check with the school to get the correct figure, because exam fee is really, it is US related, US currency related. So the fee will vary based on fluctuation of the US dollar. Is that clear, guys?
Yes, sir.
All right, so I'm going to stop here now. All right, so we will continue. We will continue.